to our quantum coding workshop. We will be focusing in, a little bit more. You probably have heard this term of, quantum information, quantum science, quantum materials. There are all these different, frameworks that people put on this idea. We'll be constraining a little bit into how does quantum computing work, and how do we write code that can work, potentially in the future on a quantum computer. I just got back from a workshop last Thursday and Friday that was, talking to educators about, what is the state of the art, trying to introduce how do we get these ideas of quantum science into classrooms, into hopefully y'all's hands. And at this point, it is possible to run on a quantum computer, to submit code. The quantum computers can't live in our classrooms here, they aren't just like our laptops, but they're at computing facilities remotely, we can log into them. And hopefully in the near future, we don't have it lined up for this workshop, but hopefully in a near workshop, we'll be able to submit code and see it running actually on a quantum computer. One of the big challenges, you're vaguely interested in this area, is partly designing the code, designing the algorithms, designing the actual things that we write, and the other half of it is pure just the engineering side. Like how do we actually get these computers to be reliable, to be fast, to be easy to work with. One of the big challenges that was coming out, or that is out there right now, is we think of computers right now as we're writing code, we're storing data on them, and we expect if I save a file on my computer, it's going to be there tomorrow. If I save something on a quantum computer, it will be there for a millisecond. It will not be there when I look again. So we need to be very careful about how we're working with them. So with that kind of setup, this is an incredibly exciting area. It's something I'm also learning about and I'm trying to integrate into a lot of the research and scientific work that I do. I want to also get to know y'all. I maybe skipped over the introduction, so I'm Dr. Ben Offlerbach, Dr. A, or just Ben is fine. And I want to, I know some of y'all from the fall, but I want to maybe go around, give me a quick introduction, and give me your pitch for, when I say we're going to do quantum coding, what does that mean in your mind right now? Like, what are you expecting? Do you have any familiarity with, coding in general and how we might tie into this? Primarily, we're going to make sure we're grabbing everyone at the ground level. We'll start out with, how do computers operate? Just like, what is going on when we think of running traditional computers? We'll definitely touch on these ideas of binary data, right? We have some familiarity with that. Talk about how we represent information. And the framework for this workshop that we'll be thinking about is decision-making in computers. We focused a lot in the fall about this idea of randomness, random probabilities. We're going to give another pitch, which is kind of coming at this from a different angle. So hopefully we'll pull in the new guys and say, how are we making decisions with computers? For those of y'all that were here in the fall, we're going to give the pitch from a slightly different angle, so hopefully we will build up and start to have a more sophisticated knowledge of different things that contribute to this field of quantum computing. So, with that very high-level maze, I'm going to I'll pose a question to y'all. Completely different in some sense. How do we solve mazes? When I say, if I said, hey, there's this maze, I mentioned this idea of algorithms a second ago. How do we solve mazes? What's going on with this maze? Anything that comes to mind. Again, specific or general as you like. Yeah, Hunter.
If you really don't want to put much thought into it, you can just follow the right wall.
Yeah, you can follow one wall. There's this classic solution, at least for simple mazes, where it says, hey, if we just stick and make the same decision every time, we will get to the answer. So that's maybe something we can keep in the back of our mind. Anything else that comes to mind for people?
You just start, right? But you go outside of the maze and then you
yeah.
see.
Just
There's
go to the
nothing
end.
forcing us going in. And if the goal is to get here, do we have to go through this whole convoluted mess in the middle? That is an amazing thought to be thinking. Like I mentioned a second ago, the idea of quantum algorithms versus traditional algorithms. Oftentimes, they go completely different directions. And you are very forward-looking in bringing that up. And that, I think that will be a big pitch for the second half of the workshop is, what are the different ways from traditional maze solving techniques? Can we ignore the middle and jump straight to the end? Can we go around the outside? Can we re-envision maybe how we represent our data, stuff like that? What if we change our viewpoint? So what if we give a maze like this? how would I describe to these people that are stuck in the middle of this maze? Fun point, I think I've been to this maze. I found this picture and I was like, wait a second, this looks super familiar. I remember these wooden arches. So how might we think of describing getting out of a maze? Maybe a slightly different context. Any other things that come to mind? We had, be consistent, make a consistent decision. But maybe this one's complex. Usually there's like this spiral over here. What if you just get stuck and you keep spiraling over and over and over? Other things that come to mind, thoughts?
Well, I mean, kind of like if you were to flood the maze with water, try every path that's possible to you, and if you hit a dead, just retrace your steps.
Yeah, if we're coming up with algorithms, I think that's a perfect idea, right? Can we get an exhaustive list of here's all my options, and I'm just going to try these out one by one? Absolutely. And I like the idea, especially filling up with water. There might be maybe an analogy we can tie like that to how do we smartly identify those paths. That's really, again, a big theme of today is how do we identify paths? What does it mean when we're setting up paths? And again, I'm sort of changing our viewpoint here. What if I said, here's us in the middle of the maze. How am I going to solve this maze? Now, we don't see any of the high-level information. I'm stuck down here, right in the middle. All I see is there's a path forward, and maybe there's something up in the future, but we don't know. Any thoughts? Anything that comes to mind? Maybe what I'll point out is this seems to be getting harder, right? I started, with us zoomed out. We had a very, grid-based view, right? It was like, hey, I can see this whole maze. It was very easy to say, hey, here's the start and here's the finish. Now I don't even know where is the start, where is the finish, right? I'm just at one specific location. Sorry?
Someone's probably moving a chair.
Oh, yeah. That might be, up above us. So we don't know where the start is. We don't know where the end is. All I can see is my local information, right? And maybe I have a goal of I think there should be an exit somewhere, but this is definitely a harder challenge. How we think about the information we have and the decisions we can make might be less apparent here. We are in a maze, we're trying to solve a maze. What does a computer do maybe that might help us solve a maze, help us make some sort of step towards solving a maze? Any ideas that come to mind?
Run algorithms to find the best possible route.
Sure, absolutely, we can run algorithms. Let's try to zoom in instead of thinking maybe of a whole algorithm. What is like the one thing that might be a part of an algorithm that a computer might do? Maybe try to zoom in a little bit.
Walk forward.
Walk forward, yeah, it might do something like change our current state. I like that idea of walking forward. So we can think of maybe some simple iterative rules. We have some sort of input. We say, hey, if I don't see anything else, maybe that last picture, all I see is a path forward. So if I don't see anything, I just walk forward. And I say, update my output, move me forward some amount of distance. Maybe if we see a choice, we say, hey, I'm going to go left, I'm going to go right. I'm going to make some sort of decision. I'm going to do it, again, based on these rules, just like Hunter, you were saying, right? These are rules that we could imagine in the framework of a larger algorithm. A series of steps, and if we just keep following those, hopefully we'll get to the solution. So another maybe framing on this, just to sort of saying the same thing in a bunch of different ways here. We can move between different states. I think I maybe said this when we had the zoomed out example, the initial maze idea. If we can see the whole maze, really the goal is to go from whatever the beginning state is to the ending state. So that let's just skip and go straight there around the outside. How do we imagine moving between these different states? So, if we feel like we're kind of understanding the situation, I'll propose, one thing we can imagine is, let's say, moving forward, we can maybe take for granted, like, hey, we're just going to always keep moving forward until we need to make a decision. I need to go left or right. In this case, I need to kind of go around the bend until I need to make a choice. If we imagine this situation, hey, we're designing an algorithm, maybe we'll take Hunter, yours was, I think, choose right every time, basically, right? I'm going to go here, I'm going to take right, I'm going to go right, I'm going to go right, keep going through this. Essentially, by doing that, we can construct something, and we'll call attention to a kind of data construct that comes up often in computing, and this is the idea of a binary tree. So I'm gonna be at some start condition. Now we'll think of our maze as just the decisions, right? It is just left and right. We'll abstract away all the physical situation of what might be going on in the maze, but if I just make these choices, I can go left, and I can go left, 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 over and over. So our right, right, right algorithm is this, basically. We could keep extending this off, right? So go to the right every time, or we could go to some intermediate. And we might be thinking of, these are all the states. These are the things that we have access to. Each combination of left and right, we could put together into a string, and we can describe with those strings, I have those in quotes at the bottom there, a series of left, right, right. I have one that's just right, right. Maybe we don't have to go to the end. Maybe I just want to stop here in the middle. And then this left, right, left. So getting down here towards the bottom left side. So if we're feeling comfortable thinking about this idea of mazes, if we can maybe map that onto imagining the situation of lefts and rights,